change this one into unsigned in. And then now this one. And 5. Okay, looks like only the I1 comparison. Okay, sign. Wait, 47. This is 4. Six, 7. Okay. Negative. Should we try prevent this from overflow, using GCC overflow built-in function? What? Okay. subtraction, right? They perform subtraction. You will see. Okay. 756. Okay. Let's say that count is 0, but well, we already have a safety code for that. Conditional where count is 0. So I think it should be fine. And then if count is 0, but yeah, if count is 0 and I is also 0, let me try that in GTP. Where are we? Pop, okay. File name. Value count. Let's start using but yeah, certainly add a safety code when cone is 0, you know. And if cone is 0, then this one can become dangerous. Let me try. Zero. Interesting. Okay. Right. because we have this one. Let me try. But 0. Alright. If I is 1, let's say, we will I don't think this is necessary, because if the count is 0 and the index is 0 or more than that, we will trigger this one. Right. Okay. Alright. Now let me continue to the chapter 11. To allow for naming values, we need to get a structure which stores the name and value of everything named in our program. The environment. Okay. When we start a new interactive prompt, we want to create a new environment to go along with it, in which is new path of input is evaluated. Then we can store and recall variables as we program. Here is a name. We're going to delete. Send a name. Reassign a name. We're going to delete that association and create a new one. So we are deleting the old assignment and then create a new one with the same name. Is that it? Then assign to that name has changed. It's multiple, but in fact we have to delete the old thing and assign it a new thing. Hello, Mr. Peace. So welcome. Currently I'm trying to learn C by reading this book. Let me copy this in the chat. And currently we are on chapter 11, which is creating a variable, I guess, to store the value with name, the naming value. Is that the name? Yeah, something like that. Basically, we need to create the environment where we can store the variable. Delete the old thing and assign it a new thing. This is the fantasy where we really can change the data pointer to by a pointer to in a struct without deleting it and get a new one. Okay. What are you talking about, Mr. Peace? Oh, yeah, I have no idea. Hello, Luigi. Welcome. We are finally moving on to chapter 11 from the book. It is creating an environment to store the variable. What is that? Yeah, I have no idea. Without deleting it and creating a new one. Symbol syntax. Now that we are going to allow for user to find variable, we need to update the grammar for symbols to be more flexible. Rather than just our built-in function, it should match any possible valid symbol. Unlike in C, where the name of variable can be given is fairly restrictive. We are going to allow for all sorts of character in the name of variable. Can create a regular expression that expresses the range of character available. Okay. Well, having plus in the variable name is interesting choice, I guess. And also this, right? Oh, and also asterisk. Yeah, this is something having the slash in the variable name and also backslash. Okay. Because we use string, we need to escape the escape character. That is why the backslash here have 4 backslash. This is escaping the first backslash character, and this is escaping the second backslash character. Okay, we have just placed our hands into the keyboard. Well, that is regex or regular expression, I guess. Actually, it is a regular expression using the bit range specifier, right? This one. So this is the range of the character that we can use, and plus means that at least one character or more, but within this range character. Inside range specifier, special character lost their meaning, but some of this character still need to be escaped with backslash. Like for example, this one, this one, because it has a meaning like range A from Z, like this one, the lowercase a and lowercase z, the uppercase A until the uppercase Z, so A, B, C until Z, and 0 until 9, something like that. That's why we need to escape the dash to make it the literal dash rather than the special character like this. And well, in string C we need to escape the escape character. It is the backslash. So we are escaping the backslash, which mean look like this, backslash dash, something like that. Because this is part of C string, right? We need to put the backslash to represent a single backslash character. But some of these characters still need to be escaped in the input. This rule, let symbol be any normal C identifier character. The arithmetic operator. I mean, I'm still not sure if this symbol gonna be, sorry, if this symbol gonna be the variable name or something else. Yeah, we will see. Maybe we will see later on. Or an ampersand, right? This will give us all the flexibility we need for defining a new and existing symbol. Okay. And this one, right? Let me change that. there is no interesting. There is no, what is it, comment, head, tail, and so on, I guess. So yeah, until set. Well, first let's try using this, and then later on maybe we can use something like this, or this maybe. Regex. Word character. Right. Not okay. See, this is this match. Not this one. This match this character, right? At least in C#, I guess. Let me check in here. What are you studying today? Okay, I'm continuing with the book, right? This book, and currently I'm trying to create the environment for storing the variable or naming value, I guess. So yeah, we will try to implement that. Okay. Wait. Is it 09 underscore? Okay. And then we have plus like this. Okay. And then this, right? And then slash. And then backslash, and then equal sign, this. Okay. Let me check. This one, and then this one. Okay. Okay. Function pointer, right? Let's take a look at function pointer previously in the playground. It's basically a function that return another function memory address. So let's say we have this main function, right? Or this add or minus function. Both of these have, or all of this function also has a memory address. So we can return this memory address and use it like we are, what is it called? Like we are using this function. Something like this. There is mosquito everywhere. Is that Finn? Yes, it is Finn. Welcome, Bran. And also Joris Jorissinia. Welcome. We are trying to learn C by following this book currently. Let me copy again in the chat. And yeah, we are in the chapter 11, trying to create the variable, trying to create the environment to store the variable. Okay. Once we introduce variable, symbol will no longer represent function in our program. Okay. But rather they will represent a name for us to look up into our environment and get some new value back from. Therefore, we need a new value to represent function in our language. We need a new value to represent function in our language. Yeah, we have, I guess, multiple functions like eval, and then tail, and then head, right? So yeah, something like that. Which we can return once one of the built-in symbols is encounter. To create this new type of alpha, we are going to use something called function pointer. Okay. Function pointer are a great feature of C that lets you store and pass around pointer to function. It doesn't make sense to edit the data pointed to by this pointer. Instead, we use them to call out function they point to, as if it were a normal function, right? Like normal pointers, function pointers have some type associated with them. This type specifies the type of the function point to it, not the type of data point to it. Like normal pointers, function pointers have some type associated with them. Okay. This type specifies the type of the function pointed to, not the type of the data pointed to. Okay, which means that the return type of the function and the parameter type of the function need to be specified for this function pointer. I mean, that's why in my example here, where is it? This one, I guess. this one is the not this one is the return value for the function pointer, for the, what is it called, the function that we want to return, the memory address of the function that we want to return. And this one is the parameter, the type of the parameter for the function that we want to return. It is well add and minus, right? The return value is integer here, and the, what is it called, the parameter is also integer. And if we change this, for example, using unsigned instead of in, it should throw an error. Let's find out. Function pointer, yep, it is incompatible, right? Return type, returning this one, the -1, right? But we want a function pointer with this, what is it called, with this parameter integer and integer. So yeah, that didn't work. Now it compile. Okay. Specify. Okay. This let the compiler work out if it has been called correctly. In the previous chapter, our built-in function took file pointer as input and return an file pointer as output. In this chapter, our built-in function will take an extra pointer to the environment. Our built-in function will take an extra pointer to the environment lenv as input. We can declare a new function pointer type called built-in for this type of function. Okay, I think I've maybe I should drop this one. Okay, the value this is okay. Currently okay, I don't think I need these changes anymore. This one too. Combine. Okay. Next time maybe we will take a look at that as a reference. Do I need this? Let's take a look at that later on. Now we can declare a new function pointer type called built-in. Okay, we are using type def. This can be put before any standard variable declaration. In the name of the variable being declared as a new type, would be infer type of that variable. Above declaration, what looks like the function name becomes the new type name. Next of this, okay. Create new in pointer x, okay. The function pointer to get an alpha, it reference output in and call it lnf and okay. The function pointer that takes in lenv and alpha and return alpha. Right, this is the return value. Okay. But yeah, we haven't defined this yet. And put in type reference the alpha type and the lnv type. This means that they should be declared in the source file. Declare first in the source file. Yeah, I think it is called forward declaration. So we declare something first and then define, let's say, the struct later on. Something like this. What is it? Struct alpha, struct env, right? And then we define the struct in this one. Okay. I mean, yeah, I don't really use type def for the struct. It's just personal preference, I guess. But in this one, I think it is easier to use type def, because if we are not using type def, then yeah, well, let me try that without type def. Okay, this one, right? Double num. Maybe something like this. If we are not using type def, I think I need to type like this. Env struct helpful, and then file. If I understand correctly, but yeah. Okay. File. Yeah, I kind of forgot. Let me check. Is it in this one? I don't think it is in this one. Maybe in pointer and array. Okay. Alright, oh. Do I need to enclose this? Like this maybe? So alpha is no member name cell. Yep, it is. Let me check. C program. Function pointer as type in struct. Number of C struct. Okay. We're using type def, right? But now, oh, wait a minute. Should we put that? Oh, should we put that name in here? Interesting. Oh, okay. This is interesting. Let me try using this one. Right, we have this type def, okay. Now if I need to create struct, alright. Struct something, and then having this function pointer in fun, let's say. something like this, and then I can struck something what is it? Not really something. Some struck. Some struck, and then what is the variable name? For, I guess. And then we use something like this. Step it. Background function pointer. Background. Oh, at least it compile. Interesting. But yeah, if we run that, for 2.1, maybe something like this. No, okay. Right. Something like this maybe. Okay, at least it compile. Let me check if there is any warning. No, okay. Function pointer. Alright. Interesting. Yes, I'm struck. Let's call it some struck. Okay, let me commit that first. Background and sample using function pointer in struct type in struct. Previously we already have example using function pointer as type def which we can use as the like normal type. Now let's try assigning a function pointer type directly in struct without type def. Okay. Let me check again. Okay. So should I use it like this? I mean, this is kind of hard to read, right? So yeah, I think I'm gonna use the type def one. Alright. We can really scroll this one. Let me hide this for a moment. See any. This is what I meant by \w. Okay. Type def alpha. Okay. Alpha, right. And this is the type name, I guess. Okay. With entity to make it easier to identify that this is the type def. I mean, usually I think people use it something like this, but there's a possibility that we might conflict with the POSIX type. So let's use tt instead. Struct env first, right? Environment first and then the value. Okay. Alpha pointer. Okay. Do I give? Did I give? What is it called? The name. Oh, okay. The name. I didn't give the variable name, the parameter name, sorry. Okay. Alright, we need to use struct alpha. Okay, let's do some refactoring. that in the last one. Okay, I make that I guess. Alpha, no, well, entity file. Right, this is easier to read. Okay. I feel. Thank you. You're welcome. Sorry. I feel like I'm not do a single project because of this. Well, maybe you can try a simple project. I mean, for me it is fun, you know. Good work. Thank you, Stan Mars. Welcome. Thank you, Luigi. By the way, how are you able to memorize all the key bindings? I think because of practice, I guess. I mean, again, I've used Vim for around 5 years, and I just keep using the key binding over and over again, and not only Vim but also Tmax, right? So, and then, well, it just feels natural, you know. I mean, at first it is hard, right? Like, for example, going up and down, we usually using arrow key. So suddenly we need to use J and K, for example, to move down or up. So it need, what is it called? I need some time to get used to it, but then I keep doing it over and over again, so it become like, what is it? Muscle memory? Is that the word? Yeah, maybe something like that. So it becomes some kind of reflex. But yeah, I don't really have any tips or trick to memorize the key binding, except for use the key binding over and over again. And let your, what is it? Let your finger memorize the key binding. Should we like decrease this version? I mean, we are using the release candidate, right? And also using this semantic version too. Yeah, I think it is kind of hard to track, maybe. Okay. But yeah, if I need to use that, then I need to change this version. Well, let's not change that, I guess. Okay. Alpha alphabet font. Alright, maybe another tips when you're trying to follow a tutorial or a book, let's say. The easiest way to learn is by changing the changing the variable name, right? So when we change the variable name, we need to slow down. We need to think, what is this variable equivalent to in the tutorial, right? And that that kind of prevent us from going to the tutorial hell, where we keep following the tutorial but we feel like we have no idea that we already learn something. So yeah, it kind of prevent tutorial hell, at least for me, by changing the variable name and not using the variable name in the tutorial as is wherever I can. For example, like this one, instead of fun, I'm trying to use fun, I guess, and to put in an L put in underscore tt instead of only L put in for the type def, right? So yeah, a little bit of tips. Changing the variable name or the function name, or maybe some kind of mechanism, in this case the tutorial using type def, right? But I don't really use type def, I use struct and then the struct name directly. So I need to analyze that, right? Translating from the tutorial code to my source code, something like that. Okay, function type, as we have added a new possible L file type with the enumeration L file fun with the enumeration L file fun. Okay, we need a new enumeration. Okay, in this one, right, alpha fun, we should update our relevant function that work on L files to deal correctly with this update. In most cases, this just means inserting new cases into switch statement. Okay, we can start by making a new constructor function for this type. Alright, alpha put in fun. Okay, malloc. Right, fun. Okay. First, we need to add the new enumeration in the type, right? Okay, fun. Should I use 0 instead of 6? Let's use 6. And then we need to create this function, right? did it. Where should we declare that? File symbolic expression. If I understand correctly, we need to, what is it called? We need to declare the function first. Is this some kind of, what is it called? The environment we are trying to create. Oh, no. This is for the functions such as head, this one. if I understand correctly. So, maybe put that at the beginning, I guess. Struct, where is it? Okay, this one. Struct alpha fun. If I can type correctly. Put entity fun. Okay. Right, we declare first and then we define the function in the C source code. And as far as I understand, it is kind of the format for C library, I guess. Yeah, at least that's what I learned. Which I'm not sure whether that is correct or not. Okay, anyway. Alpha fun. Okay. Let's put this in here. Static, okay. Alpha, oh. Should I? Should I put this at the bottom though? With an operator? No, I don't think so. Okay. Let's fun. Let's put it in here. Right, we are trying to represent this one, if I understand correctly. So let's put the alpha fun in before the built-in head. Built-in head. This is the operation. This is the operator. Okay. Struct alpha built-in. Not really built-in. Fun. I'll put in type def fun, and then we define the function. Okay, we are using malloc. Alright. Okay. We are returning struct alpha, right? Okay, yep. Alpha value and then malloc size of value. Okay, what this means is that, well, size of is evaluated during the compile time when we compile the source code, and this one means that we get the, what is it called? We get the value pointer type, not really the value but the type. So we get this type, struct alpha, and this is convenient because when we change the, what is it called, the value type, right? This is the value, right? The value type, let's say we change this to env, right? We don't need to change this size of operand. It will automatically evaluating to the new type. That is quite convenient to do. Okay, and then we need to handle the malloc. Just copy this, right, and then alpha fun. Value type alpha fun, and then value, what is it again, fun. Now we are returning the value, right? And the value, okay. Until listen, we don't need to do anything special for function pointer, okay. Alpha tail, so that means, maybe let me put this in at the left side. It means that we can use this, like if we are gonna break directly, we don't need deletion, okay. On printing, we can just print out a nominal string, okay. That's it. Alright then. Print, right. Okay. Maybe in this one. Printf function and then break. Oh, okay. We are also going to add a new function for copying on L file, Lisp value. Okay, this is going to come in useful when we put things into and take things out of the environment. Okay, when we insert or take out the variable value, I guess, from the environment, right? For numbers and functions, we can just copy the relevant fields directly. Numbers and functions, we can just copy the relevant field directly. For string, we need to copy using malloc and strcpy. Well, honestly, it depends. I mean, if we are using string literal, which have static storage, I don't think we need to use malloc and strcpy to copy the string, because it is already saved in the binary file, I guess. So it is static value. To copy list, we need to allocate the correct amount of space and then copy each element individually. Allocate the correct amount of space and then copy each element individually. List. Okay, list. I think list in here mean the cell. Where is it? Is this one? Right, in this one. For the list or cell, the correct amount of space and then copy each element individually. Okay, copy function and numbers directly. Copy string. Again. But yeah, if x is the, what is it called? If x is the environment, right? Then I guess we need to copy that. I mean, there is a chance that we delete the value, right? We are free the error message allocation. I mean, if we use the previous error message, which only use string literal, I don't think we need to use malloc and strcpy. And maybe I should use str and cpy instead of strcpy to give the size, right? But yeah, why is it different? Oh, it have different manual page. Okay, interesting. Fill affix size buffer with non-null byte from a string. Padding with null byte as needed. Okay. I think null byte in here means the null terminator, the \0. Okay. Copy non-null byte from string. Okay, maybe we will explore this in the next session. Alpha copy, right? Alpha copy. Maybe in this one. Before the built-in one. I mean, I'm still not sure where we are gonna use that. This copy mechanism. So yeah, for now let's declare that in here. Okay, alpha struct alpha pointer. Okay, value. Let me put the 2 in here. Check. I mean, the concern with strcpy is the buffer overflow. It's basically we are trying to access the memory, the inaccessible memory, something like that. Check how strncpy works, and if I remember correctly, I've already tried. Wait, oh, why is it? Okay, I haven't tried using strcpy, the string copy mechanism. Okay. Alright, so I guess that's it for now. Thank you for watching and see you next time.